We already discussed about the basic recursion, and we already learned how we can do the binary search. So let me review a little bit about this binary search. When we are having one kind of list, we can search a number. Let's say I want to search 22. So instead of doing the search one by one from index 0, we can do with this binary search by finding the low, mid, and high. After I found the mid value, I will check where is the position of 22, whether it is higher or less than the mid. Because it is higher, then we will just focus on the right part. If we check the mid equals to the target number, then we finish. But if it is not, we again check whether the target is less than the data mid or the target is greater than the data mid. And here again, we will check and check until we find the mid value, which is the target value. If the low equals to mid equals to high, then we can say that we find the number. And from this operation, you can see that we have like approximately 4. Okay, we have 1, 2, 3, 4 operations. And we call this is the log base 2 of n. You know n? N is the number of the data. We have 16 data. So we have log base 2 of 16. And the result is 4. Okay. We call this is the worst case scenario. Therefore, we can compare the binary search and the simple search. In the binary search, we have the big O notation, which is O log n. It means the remaining portion of the list is of size high minus low plus 1. After one comparison, this becomes one of the following. So after you compare 1 at the first time, when the number of the data equals to n, so you will have the mid minus 1 minus low plus 1, which is equal to the low plus high divided by 2, which is to find the mid, minus low will be less than or equal to the high minus low plus 1 divided by 2. Maybe the simple say is every time we want to check, we will always have the number which is lower than or equal to this number. High minus low plus 1 divided by 2. High minus low plus 1 divided by 2. Regardless you go to the left or regardless you go to the right section from the full data. Thus, its recursive call divides the search region in half. So we always make half. And there can be at most log n levels. So if we have the data is 16, then there might be approximately 4 levels. If we do with the simple search, we have the ON, because it will go to every element and at least, or the worst case, it will be until n. So if you cannot find the number, let's say I would like to check 24. Is there any 24? you check index 0, 1, 2, 3, 4, 5, and so on until index 15, but you cannot find 24. So the worst case will be until the end, and it takes n time. That's why we call this is the for n. In this case, the worst case, it will be log n. Even though you cannot find, it will still be in this operation time. So that's the basic recursion. What I want to discuss next is some concepts on the recursion. The first is the linear recursion. What you already learned before, it was related to linear recursion. The linear recursion means we have tests for base cases, as we already learned. We always need one base case. It is begin by testing for a set of base case. We call it a set of base case because the base case can be more than one, or the condition can be more than one. But there should be at least one base case. Every possible chain of recursive calls must eventually reach a base case. And the handling of each base case should not use recursion. In the previous example, we have the base case is straightforward, equals to 1. And it recur once. So we have the recur once means, it should perform a single recursive call. So there should be one time to do the recursion. This step may have a test that decides which several possible recursive calls to make. But it should ultimately make just one of these calls. So you can define its possible recursive call so that it makes progress toward a base case. Let's say this example, I guess, is similar with what we already learned in the previous example about factorial. I have this algorithm, linear sum a comma n. Let integer array a and integer n equals to 1. And a has at least n elements. So I would like to have the sum of the first integer and integers in A. Let's say if I have 1, 2, 3, 4, 5. So I want to find what is the summation of these numbers. If n equals to 1, then return A0. So A is a list, okay? And A0 means, we just return number 1. But if not, then you can do the linear sum. And the linear sum, you can see this is the algorithm, the method that you define, and n minus 1. So we will decrease the number from n until 0. And then we want to plus with the a n minus 1. It means if I call the linear sum a comma 5, we will do the checking 5. If n equals to 1, no, then we will call this one a n minus 1. A minus 1, n minus 1 means 4. So we will do the linear sum, the data in the list A, and then we will do the 4 plus the A index 4. And then check again. What is n? Because n is 4. N equals to 4? No. Then we will do another linear sum. A equals to 3. So we will do the linear sum a comma 3 plus a index 3. And so on until we reach the a comma 1. When n equals to 1, so we just written a index 0. So it depending on the number, of this list, or maybe this is the number, this different number, and we will do the summation. Let's say this is 4, and then we have 4. Okay, this is 3. Okay, so and then this is 7 will be the result of the summation from the previous numbers, and we will add 6. So the result is 13, and the result will be in the next iteration, and then we will add with the number, in this case 2, which is 15, and we go to the last one, 15 plus 5, and it will be the number 20. I guess this number is the index, the list will be like 4, 3, 6, 2, and 5. So we have this list, and we want to find every, we want to check the elements, and we want to do the summation for all these elements. Linear, we just want to check one by one. We can also do the different kind of recursion. We call it the reversing array. We have a problem to reverse the array. So let's say this one is an array A. We have array. Maybe you can just think that it is a kind of list. List is one of the type of the array, or it is the general type of array. In a list, you can put any object. Let's say you have string, and then you have number, and then you have the float, and so on. Okay? You can have multiple objects. We will learn about array in the next session. And we have the array, and the numbers are non-negative integers for the index I and j. You know that if we have array, we will start always from 0 index. Sorry, in 0 index, and 1 and 2 and so on until n. When we have this kind of array, I want to change, or I want to swap. Let's say I have 4, 3, 2, 5, 6. Okay. I want to swap it. What is the meaning by swap? Change the position. So the last position will be the first, and the next second last will be the second first, and then the middle will be the same, and then the second first will be the second last, and then the first will be the last. So that's meaning by swap. The output is the reversal of the element in A starting index I and ending at index j. So we can do something like this one. If I is less than j, so this one 0, 1, 2, 3, 4, and let's put the I equals to a kind of value from 0 and j is the length of the index A, the array A. Then if I is still less than j, we will do the swap. So this is the pseudocode. We will change the A0 with the position of AJ, which is the last one, the length of A, minus 1. Of course, you cannot do with the length because the length will be more one number. And after we have the swap, we will call again the algorithm. We will go to the next. What is the next? We still use the A, and the index here will be added by 1, and the index here will be minus by 1. Okay, so it will be until the middle. If it is in the middle part, it is in the mid value, then stop. You don't need to reverse again. We can also do with this kind of reversing array. We can define the argument for the recursion. So it can have the method. So every time we want to make this kind of recursion, we need to make a function. We need to make a method. And sometimes it requires to define additional parameters. Okay, don't afraid to make more parameters. For example, in this case, we can define the array reversal method as reverse array A, I, j. So not only one parameter, but you can have several parameters. So this is the code. Okay, you can try by yourself. If we have the function reverse s and start, stop. So we have the start is less than stop minus 1. Then let's change the position. And then we will do the recursion. Computing powers. You know, when we have the exponent, let's have the p is a function, and then x is a number, and n is another number. So if we have these two arguments, the function will be x power of n. So for example, if I have p and then I have a number 2, 3. So the result will be 2 power of 3. Okay. If I have p 3, 2, then the result will be 3, which is the x, and then power of 2. If n equals to 0, then the result will be 1. So any number, when we have the exponent equals to 0, it will be 1. If not, then we will have this recursion function. X multiplied by p x, comma, n minus 1. So I can say, like, if it is 2 power of 3, it means it is the same with 2 multiplied by 2 power of 2. And it is the same with the, if we want to decrease again, 2 multiplied by 2 multiplied by 2 power of 1 until it reaches n equals to 0. So if n equals to 0, then 2 multiplied by 2 multiplied by 2, and then the last will be multiplied by 1. This leads to a power function that runs in on time, because we are doing with the recursive. We can do better than this. How? So we can have the recursive squaring. What does it mean by recursive squaring? We can derive a more efficient linear recursive algorithm by using repeated squaring. For example, if an x is odd, you can do it this one. But if an x is even, you can do with this formula. For example, 2 power of 4. So 2 power of 4 is even. The x is even. Maybe not the x, sorry. The n. Okay, sorry, the n, not the x. Okay, I will change this one. So you can see if it is 2 power of 4, then it will be 2 power of 4 divided by 2 power of 2, or multiplied by 2. And then after you have this one, it means 2 power of 2 multiplied by 2. Here you will get the 4, which is the result of this one, power by 2. But if you have the number is an odd, so you will have 2 multiplied by 2, 4 divided by 2 multiplied by 2. So this is the 2 when the n is odd. This is the case when the n is even. And you will have 2 multiplied by this function. And then you have 2 multiplied by 2 power of 2 power of 2. And then you have the 2 multiplied by 4 power of 2. So we will get the result is 32. So when you have the even, you will do this one. If you have the odd, you will have this one. We can also make this one is in more efficient way. This will be the algorithm. If it is like the n is odd, then you will just do the function like n modulo 2 not equal 0. If it is odd, then if it is not odd, if it is not divided by 0, then it is odd. If it is divided by 0, it is even. Then you can have this power function. If it is odd, if it is not, then you will have this power function. And the power function is power x comma n. It will return x multiplied by y multiplied by y for the odd, if n is odd. And if it is even, it will be only y multiplied by y. And then the base case is n equal to 0, and it will return 1. Each time we make a recursive call, we halve the value. So half the value. It will make it as a log n. So when we can halve it, yeah, it will make the operation time reduce by half. And if we can reduce it by half, then yeah, there is a possibility to make your operation will be log n. So it is important that we use a variable twice here rather than a calling method twice. Okay. The recursion variants. Yeah, there are some other additional variants. We can have the tail recursion. We can have binary recursion. What we already learned before, it was related with the linear recursion. Linear recursion, we can have the tail recursion, we can have binary recursion, we can have multiple recursion. Okay, I guess the time is limited. I will discuss the tail recursion and the binary recursion in the next class.